Hey there, here is the video recording for lesson 613, and it's about what we call upper and lower bounds. So I'm just going to put the target here, and then I'm going to talk to you about a way I've changed this. I'm listening to your feedback. Some of you have been writing to me a little bit about some of the difficulties you're having. So I think you might find this just a little bit easier. All right, I'm hoping. So anyway, the target is to graphically determine an upper and lower bound on a prediction made from a linear best fit model, or what we call a linear regression, and then determine the margin of error. So really the goal is to determine a margin of error. Okay, so the process for today is I'm going to upload a Google Doc to Google Classroom, and it will have questions on it about my process. So instead of having you stop the video and solve problems yourself, I'll be doing the problem solving, but I'll have you answer questions about my process, right? And let me know if you like this better. And if you do, this might be the method that I use more often. All right. So the problems that are what we call the core problems for this lesson are 622 and 623. So I've just actually copied them from the book. So if you wanted to take a look at your textbook, it's section 613. It would give you a more full picture of what the problem is about. All right, so anyway, here's what it says. In 1997, an anthropologist discovered an early humanoid in Europe. As part of the analysis of the specimen, the anthropologist needed to determine the approximate height of the individual. The skeletal remains were highly limited, with only an ulna, or that's your forearm bone, being complete. The bone measured 26.4 centimeters in length. All right, now, if we had been in class, we would have been going through the process of trying to figure out, all right, what's the important information here? What can we do to figure this out? What data do we need? So instead of that, I'm just going to kind of let you know, if you look at this, you can see, well, what might be important is to know heights and forearm lengths to see if we can find a relationship. And then from there, we could basically determine approximately what height this humanoid was. All right, so because we're just all doing this weird thing, we're all at home, we're going to use data that the CPM book provided. All right, so here's the data that they provided for us, just in case we couldn't get around and we're in that situation. So you can see they've got the forearm length and the height. I want you to think for a second about which would be the dependent variable and which would be independent. All right, so basically, yes, the independent variable in this case is the forearm length, because the way we're thinking about it is the height of the person depends on how long their forearm was. All right, so this is some data that was provided, and this would be data about early humanoids and their forearm length as compared to their height. Okay, so 623, question A, has several little parts to it. All right, so here's what basically you would be asked to do in 623A. Look at the data you collected, and the line models the data. Identify the point that is farthest from the line you drew, and then calculate the residual for this point. Okay, so what I did is first I just went to Desmos Graphing Calculator. I typed in all of the points that the book gave us, and then I had it graph the points out on their graph. All right, so I just put a copy of it. All right, so that's my first step. I just wanted to review this. I thought this was a good opportunity to just review describing associations, and this time maybe putting some vocabulary with it. So there are really 4 parts to describing an association. I often only ask for 3, but I'm often leaving the outliers out. So the form is it linear or nonlinear? And as we get more specific, is it exponential? Is it quadratic? Is it some other function? Right? So for now, though, we're just saying linear or nonlinear. I think this one is linear. The direction is it positive or negative? I felt that this one was positive because as you're going to the right, you're going up. I felt the strength on this one was moderate. Better than weak, but certainly not strong. And I didn't find any outliers in this situation. Some of them are a little bit far apart, but no outliers, in my opinion. All right, some of that's quite subjective. All right, so you can see this time on the graph, I have a line here. All right, so again, I just put this in Desmos Graphing Calculator after I figured it out. So what I often do is choose 2 points that are basically data points. This is not necessarily the best way to do this. Really, the best thing to do is to find a line that you think really goes in the middle of the data. And again, I want to say this, that's just eyeballing it. As we go along in this chapter, we're going to find that there is an exact way to do this. So we actually do have the true line of best fit. We're not quite there yet. So at this point, we're still estimating it. All right, but anyway, you can see what I did. I chose 2 points on the line. I chose 23, 143 and 29, 185. And you can see it actually creates a line. I've got 3 points below it, 3 points above. So first thing you do, quick review, find the slope. Now I did not plan this. All right. This whole line comes out to be really nice, and it was all just by chance. So it's kind of cool. But anyway, 185 minus 143 for my change in y's, 29 minus 23 for my change in x's, 42 over 6, that divides to be 7. So then I plugged in my point 23, 143 to determine b. So you can see my calculations there. I ended up with the y-intercept of negative 18. And again, because we're talking statistics, we often put the y-intercept first and then the slope. So I have y equals negative 18 plus 7x. And Desmos doesn't care which way you put that in. It'll still graph it. All right, then the next thing that we had to do for this question is identify the point farthest from the line. This was pretty easy for me to figure out. All right, it's this one. I just had to eyeball it. So it's 24, 175. Then we had to actually figure out the residual here. So what I did, and you can do this right on Graphing Calculator, if you just hover over the point, it'll give you the coordinates. So I just held my, basically held the arrow over it, held the pointer over it, and I got 24, 150. Again, you guys, I did not plan this. So my residual is the actual amount, 175, minus the predicted amount, which is 25. All right, and it's clear it's positive because it's up 25. All right, hopefully that makes sense. All right, then here's sort of the new part. All right, so I'm going to put my picture right here in the middle here. All right, it says in a different color, draw a dashed line that goes through this maximum residual point and is parallel to the line of your model. Then draw another dashed line that's on the other side of your model and is the same distance away as the first dashed line. You have just drawn the upper and lower bounds for the variability of the data. There, that's how you do it. That's how you get the upper and lower bounds. All right, so here's how I did it. My residual was 25. So all I did is I took my previous line, which was y equals negative 18 plus 7x, and I added 25 to get a different y-intercept. I want a y-intercept that's 25 points higher than my original. So negative 18 plus 25 is 7. You keep the slope the same, so you can see in both of them it's still 7x. So then my top line, my upper bound is y equals 7 plus 7x. But then for my lower bound, I want to go down 25. So all I did was negative 18 plus negative 25. That gives me negative 43. So my lower bound is just y equals negative 43 plus 7x, same slope. So you just find the highest residual, and then what you do is you add it to the y-intercept, and then subtract it from the y-intercept and graph those two lines, keep the slope the same, and you've got your upper and lower bounds. All right, then it says to use the upper and lower bounds that you just drew. Put my face right down here. Use the upper and lower bounds that you just drew. Create a range of values for the possible height of a humanoid with a forearm of 26.4 centimeters. Okay, so what I did was I plugged in the 26.4. Right, so basically I just put that where my x is, and then you can see my calculations here. Right, using my equation, I figured that the humanoid must be 166.8 centimeters, right? But we've got to deal with the variability in the data, and this is always true in statistics. if there is a margin of error, and you can see I've got the definition for margin of error, you have to report that. Now, as you get into a higher level of statistics, you'll learn things such as standard deviation. It's a little more sophisticated, but margin of error is a good place to begin. So a margin of error is basically, it allows for some miscalculation. All right, so if you look over here at the lower right, you can see all I did was I wrote what I got, 166.8, and then I wrote this, plus or minus 25 centimeters. That means my margin of error is 25 centimeters on either side. Right, now sometimes that is figured out as a percentage, so then we would just figure out, all right, 25 is what percent of 166.8, and I haven't figured that out at this point, but a lot of times margins of error are given as a percentage. This is a fairly high percentage. This is not a real close situation. All right, so that is margin of error, and that's how I would write that response. Okay, so here's what I'm going to have you do. Hopefully you've been pausing a little bit and answering some questions on the Google Doc as we go along about my process. I'm also going to want you to look at an article from Scientific American talking a little bit about ratios in the human body. It's pretty interesting. Our bodies have some interesting mathematics to them. Some even claim that the human body somehow has some golden ratio properties in it. Not everyone agrees with that, but there are some ratios that are pretty clear for the human body. All right. Thank you for listening.